What exactly is GAN, also known as Generative Adversarial Network? Let's try to understand. So to give an example of capability of GAN, one of the capabilities, this image that you see here is a completely fake image. It's taken from this website, thispersondoesnotexist.com. You may have seen images like this created by large language models with multimodal capability, but GAN is a completely specialized kind of setup where you can produce extremely real looking images of one particular kind. So in a nutshell, this is how GAN works. You have two neural networks. The first neural network is called as a generator. So this is a simple neural network. So don't mind the shape. This is another neural network, the second neural network, also called as discriminator. The purpose of the generator is to produce an image, and then the output of the generator is one of the inputs that goes into the discriminator. So how does generator produce this image? Generator will start with some random noise as the input data, and initially its weights and biases will be random. So it may produce an image that may look like random, which means it will be classified as fake by the discriminator. So the discriminator's job is to produce an output between 0 and 1, where 0 means fake and 1 means real. So, and generator's job is to produce an image which the discriminator is likely to classify as real. So these two neural networks are constantly updated with opposite goals. Generator's goal is to produce a good image which looks real compared to the dataset, and discriminator has the job of identifying fake images. Now, what happens is, in the loss function that we define for the discriminator, if the discriminator is, let's say, predicting 1 for a fake image, then it's not good, right? So then the loss should be very high because they were supposed to predict 0 if the image was fake, but the discriminator instead predicted 1. Then the loss will be maximum because you are predicting the exact opposite. Now, in that case, in that particular case, generator succeeded, right? Because generator will have minimum loss because the goal of generator was to make the discriminator predict 1, and it indeed predicted 1. So this was the goal. 1 was the goal of generator, and discriminator made the prediction 1. So the difference between this, which is one measure of loss, is now minimum. So this is what is used to construct the cross entropy loss function for both of these neural networks, and training is constantly happening such that eventually the discriminator will have something like 0.5 as the output for fake images, as well as real looking images, because discriminator can no longer say what looks real and what looks fake, because the images generated by generator will be so good looking. So this face of this person or this kid is a very good example. If you show this to somebody, they will not be able to say that this is a AI generated image. And this is, you can see this is very different from the kind of AI generated images you get from, let's say, ChatGPT, because this is based on GAN. Now, if you want the GAN to produce images which resemble an outdoor environment or something like that, you have to train it on that kind of specialized data. So for specialized tasks like this, GAN is significantly better than multimodal LLMs.